So there's been a lot of talk recently in the development community about Microsoft's new framework, .NET Core. .NET Core is the biggest thing to happen to Microsoft developers since probably .NET came out. So what changes have Microsoft made, and is it ready for the prime time? Today, we're going to jump right in and take a look.
Alright, so the .NET framework has been with us for about 16 years, first announced at the company's Tech Ed back in 2000. And in that time it's been very popular. When it was released, it was seen as a product specifically designed to compete with Sun's Java, which was taking away customers from Microsoft in the enterprise space, due to its cross-platform capabilities and a language that was seen to be easier and more productive than C or C++. So Microsoft's C#, the main language behind .NET, did not really see off Java, as Java is still popular today in lots of Android apps and back-end business systems, but C# did prove very popular for developing business applications. The company also evolved the language at a more rapid pace than Sun did with Java, showing just what a well-financed, capable commercial software team could do opposed to an open-source, community-driven process. So ASP.NET, co-invented by Microsoft's own Scott Guthrie, was seen by most as a big upgrade over the old ASP active server pages as a framework for both enterprise and web apps. So why would Microsoft complicate the .NET framework by creating a fork called .NET Core? Well, the .NET framework was monolithic, and its internal dependencies too complicated to fuel Microsoft's new cross-platform ambitions, while leaving a small device footprint. And particularly, the company wanted to compile .NET code natively across platforms without the need for a runtime installed. There are many benefits of not having a runtime. These include faster startup, faster performance, especially on mobile platforms. It also makes for a much cleaner and simpler deployment process. Another problem with the runtime is, if your application is dependent upon a runtime, then operating system changes and upgrades can cause compatibility issues and stop your application from working. The compatibility burden of all of this tended to end up with Microsoft and just slowed down the development of the runtime library. So Microsoft's solution was to refactor the .NET framework into a new modular system, while still maintaining the existing version for compatibility. This new version is .NET Core, and it was first used in Windows 8 apps. That's why the .NET Native project initially targeted only store apps. As we said earlier, the previous version of .NET came out in the early 2000s, and it had a similar idea to Java, where you compiled into an intermediary language. And with Java, that ran on a virtual machine. But with .NET, instead of a virtual machine, we used just-in-time compilers that would turn that intermediary code into actual bytecode capable of running on the native machine. Now, this was designed to give good portability like Java, but with much better performance. The new version of .NET Core, has a new compiler called Roslyn. Now, Roslyn is written in C#, and Roslyn compiles C#, which is a bit strange, because in university I don't remember any examples of compilers compiling the language they're written in. Anyway, let's jump in and take a look at the pipeline.
If we look at this diagram, you have ASP 4.6, which is everything you'd expect from Visual Studio ASP.NET project. If you want web forms, it already has web forms. If you want MVC, it has MVC. And you'll start off with a fully featured start point from building your web app. In this approach, you get the stuff which is great when you need it, but in general, everybody gets it, no matter what you actually really need. So over on the right, we have ASP.NET Core 1.0, which is a unified framework, which means they've merged MVC and Web API controllers, so they're just one controller type now. You should note that both of these frameworks will run perfectly well on .NET Framework 4.6 on Windows if you want to do that. Now we can also see that ASP.NET Core spans both frameworks, so if we wanted to, we can choose to run it on the .NET Core framework. That means that we can run it on Windows, Mac, or even Linux. Now, there isn't quite as much functionality in the standard ASP.NET Core project in comparison to an ASP.NET 4.6 project. However, you can see the path Microsoft are on, and it won't be long before you can get pretty much all the functionality you could in .NET 4.6 framework and the new .NET Core framework through adding modular NuGet packages as they come out on the new platform. So what we're getting at here is that .NET Core is designed to be modular from the ground up, meaning that instead of assemblies, developers deal with NuGet packages. Unlike .NET Framework, which is serviced with a Windows update, .NET Core relies entirely on its package manager to receive updates, which means you don't have to wait for Microsoft to release a new version of the .NET Framework to get an update, which typically only happens every 18 months. This could be quite important, for example, if you have a security fix in a particular .NET library that is used to, encode passwords or something like that. The previous .NET framework used a just-in-time compiler, which generally performed pretty well, although sometimes you might notice some slowness the first time running an app. But once it's run for the first time, it's cached a bunch of stuff, and it generally runs a lot faster. The .NET compiler platform, better known as its codename Roslyn, is a set of open-source compilers and code analysis APIs for C# and Visual Basic from Microsoft. The project notably includes self-hosting versions of the C# and VB.NET compilers written in the languages themselves. The compilers are available via the traditional command line programs, but they're also available as APIs, which you can use from within the .NET code. Roslyn exposes modules for syntactic analysis of code, semantic analysis, dynamic compilation, and code emission. Microsoft have also created extensions for using these APIs. So for example, you can have IntelliSense over C# code in Sublime or even Emacs, if those happen to be your favorite editors. In Roslyn, we have a fully managed compiler pipeline, which we can hook into and extend. It's also much faster than the previous compiler. Underneath the compiler, we have the base class library that the just-in-time compiler, also rewritten for this new version of .NET, uses. In .NET Core, we have an improved just-in-time compiler, and it's called RyuJIT. With RyuJIT, the compilation process is done only once, and a link is created between the bytecode and the corresponding compiled code. Okay, so now we're done with the theory, let's go ahead and create a .NET Core project and see what it looks like in practice.
Alright, so I think the next step in us learning about .NET Core is to go right in there and create an application. Now before you do that, you'll need to install Visual Studio 2015, you'll need to upgrade it all the way up to Update 3, and you'll need a copy of the Visual Studio Core tools, currently at version 1.1, but that might have been totally superseded by the time you're watching this. So you can either go away and do that now, or just keep on watching. We're going to jump right in there and create a .NET application.
Okay, so first off, you'll probably want to head over to .NET, which is .NET like that. Now, if we look at over on the left, we can see there's a link to download Visual Studio 2015 and Update 3, which you'll need for working with .NET Core. Alternatively, these days, if you want a more lightweight editor, you can get Visual Studio Code from code.visualstudio.com. This is a cross-platform editor, so it's great if you want to work on a Mac or a Linux machine, or if you just want a more lightweight editor for Windows. I've already downloaded and installed this. You might want to do that now. If we scroll down further on the .NET page, we can see there's a live editor window, there's an output window, and a big run button. So if we click run, it says compiling in the cloud, and then it gives us our output of Hello World. So to make sure that's really live, let's add a for loop. We'll say I less than 5, and we'll increment I every time we iterate the loop. And there we go, 5 Hello Worlds. So let's click on the .NET Core link. Okay, now at the top of the page it gives us some instructions for installing .NET Core, which talks about Visual Studio 2015 Update 3, which we discussed already. It also has the Visual Studio .NET Core tooling, which you might want to download and install. I've also done that already. Now, further down the page, it talks about initializing an application from the command line. And more specifically, it talks about a new command called the .NET command. Now, this .NET command is called .NET CLI, Command Line Interface, and it's an important part of the new .NET Core. So let's take a look at that now. To access the .NET CLI, once you've got .NET Core installed, simply open a command window, or a PowerShell if you prefer, and type .NET. So let's go ahead and do that now and type CMD to open up command window, and we'll type .NET. Now if we maximize the window, we can see version 1.0.1, which is current. We can also see that there's a help option, so let's type .NET help. Okay, so we can see there's a new command for initializing and scaffolding new projects, restore, build, and run commands. So let's have a look at these commands now. First off, I'm going to change into my code directory, and I'm going to make a new directory called Hello World. And I'm going to change that directory. Now we're going to type .NET new, and we're going to say help. Now from the help options, we can see we can specify language, and since we prefer C# projects, let's type .NET new, and we'll specify the language to be C#. And it says created new project in Hello World directory. So if we list out the directory, we can see it's created a program.cs and a project.json. So at this point, let's show off the new Visual Studio Code. We can do that by typing code, and we tell it to open the current directory by saying dot. Okay, so it's loaded up in Visual Studio Code. Currently, it's acting just like a text editor. There's none of the colors we would expect with Visual Studio. Doesn't seem to be any IntelliSense. But Visual Studio Code is already advising us to download the C# tooling extension. So let's go ahead and do that now. And we'll click install. Okay, so now it's installed, it's asking us to reload. Let's click reload, OK. The C# tooling is actually provided by OmniSharp, which is an open source project with the goal of providing you with a great programming experience in C#, no matter what editor or operating system you might choose. So now we've got the tooling installed, we can see that we have C# syntax coloring, just like we would expect. Let's alter the program code a little bit and make the message our own. We'll say Brave New World, and go ahead and save that. Now if we have a look at project.json, we'll see that there aren't currently any dependencies apart from the dependency on .NET Core itself. So if we go back to the command prompt, we can do a .NET restore. That will restore any packages in the project.json. We can then do a .NET build and build the project, compiling Hello World for .NET Core app version 1.0. So it compiled without any errors. So I guess now we can go ahead and do .NET run, and we can see the output Hello Brave New World. We could actually do a run without a build, and it would build it first. Okay, so let's go ahead and create our first .NET ASP MVC web app. To do that, we'll open up Visual Studio and we'll create a new project. So we'll click New Project. Now straight away we can see we've got the option of creating an ASP.NET Core web application for the .NET Core framework or for the full .NET framework. We're going to choose the .NET Core framework and we'll call it My First App. Now from the available ASP templates, we could choose an empty application if we wanted to start from a more minimal feature set. Then we could add packages as we go. But for the purposes of this demo, we're going to choose a web application. We're going to add some authentication. We're going to say individual user accounts. And we're going to choose not to host it in the cloud. Now what's happening here is the template will add a bunch of stuff for us. It'll add identity, and it'll add a number of client-side libraries such as Gulp and Bower. It will import the .NET pieces as NuGet packages, and the client-side packages as Bower packages. So if we have a look at the project, there should be a bunch of things you're familiar with. We have our views folder, which has a familiar Razor views. We also have our controllers folder, which has the controllers which have the logic to serve those views. And if we go ahead and run this website, okay, so now the website's loaded up, we can see we've got a pretty fully featured website straight out of the box. It's got a home page, it's got an about page, contact page, and it's got register and login for users. So if we close that and we go back into the project, and we scroll down to project.json, we can see this time it's added a bunch of dependencies. Now, if we want to see those dependencies in Visual Studio, we can click on the References tag, expand the .NET Core app, and here we can see a list of the same references. Now, a really cool feature is, if you click on one of these references, you can see a breakdown of its sub-references. Also, if we go down to Dependencies and click on the Expand the Bower tab, we can see a bunch of Bower packages that have been imported. Also, if we click Manage Bower Packages, we can see all the JavaScript libraries that are installed, and we can browse and we can add new libraries. There's Font Awesome, Angular, Animate.cs, loads of packages available via Bower. To reinforce the idea that our web application in .NET Core is just one big console application, if we scroll down and open Program.cs, we can see there's a main method. Now in the main method, we set up a new web host, specifying it to run the Kestrel server, and we also wire up our startup class. Now anyone who's got experience in creating console applications will recognize the main method as the standard entry point into their program. And the same is true with .NET Core. So another feature that I want to mention is called tag helpers, but it requires some background knowledge first to properly understand. So in traditional MVC, we typically used HTML helpers in a view to render HTML content in a shorthand Razor notation. A HTML helper in most cases is just a method that returns a string. Typically a view is bound to a model, and you can use HTML helpers, for example, to display the fields of the model, or to display input boxes where we can edit the model data. You can build an entire MVC application without using a single HTML helper, but HTML helpers make your life as a developer easier, and by taking advantage of HTML helpers, you can build your views with far less work and typing. For example, a HTML helper would look something like @ht, and then a common one was editor4. Then we'd use the lambda syntax to select a property. So what's the problem with HTML helpers? Now this looks okay, but when you start adding attributes to the action method, you end up with something that looks like this. So as we can see, when we're passing attributes, we have to define an anonymous class and remember to type out and include all the properties our Razor method requires. It makes for an unsightly mix of Razor and HTML, and it can get quite hard to read. When you're passing around a large number of HTML attributes, for when you're working with Razor, for example, it gets very difficult to read. So to fix this problem, the .NET MVC team came up with the idea of tag helpers, which is confusingly only a very slightly different name. Okay, so what are tag helpers? They're a set of special tags that mean you no longer have to use Razor helpers to build your CSHTML forms and views. If we go to the contact page, so previously we had to write an action link like this with a label, an action, and a controller. we can now instead write a HTML tag like this. This means you can create views that look like HTML rather than an unwieldy mix of HTML and C#. So we've seen the action link. Now let's take a look at some of the other tag helpers available. So the form tag helper looks something like this. The properties ASP action and ASP controller are the same as on the anchor tag, but notice the ASP anti-forgery property. Setting this to true is the same as invoking the old @HTML anti-forgery token helper in the old Razor, which by the way you should always be using. This helper is simply making your views a little bit cleaner. Next we've got the label tag form where ASP4 is the property on your model which you're passing into the view. The input tag is, now in the old syntax there were many different kinds of input tags. There was date, checkbox, text, radio, etc. And each kind had a different Razor helper. Now there's just a single input tag with two attributes, ASP4 which relates to the property on the model, and type which could be checkbox, text, radio, etc. So it's a lot cleaner. Next we've got the environment tag helper. Now this is really interesting because the contents of the helper only get rendered if the HTML is deployed to a specific environment. Now just to show you that tag helpers aren't magic and they're accessible to the developer, let's go ahead and create our own custom tag helper. Okay, so a tag helper is basically just a class that implements the interface iTagHelper. We could create our own custom tag helper by just simply implementing this interface. However, the preferred method is to derive straight from the class tag helper. Let's go ahead and look at a very basic tag helper now. I've called it AJ tag helper in honor of your host. Now here we're inheriting from the tag helper. The name of the class is AJ and then tag helper, and that's important. To actually do anything useful here, we need to override either the process or process async methods. I've left the body empty for now as we won't be doing any processing right now. Now to actually use this tag helper, we need to add a Razor directive called add tag helper. Now if we wanted to add this just to a particular view, we could just add this directive straight onto the view, but I've added it to view imports so we can use it in all our views. Now if we go here, you can see our tag. Alright, one thing to note here, the name of the tag element comes from the name of our class without the tag helper suffix. And the rest of the name is converted to what's called lower kebab case from what's called camel case. What this basically means is that every capitalized letter in the name will be split with a hyphen. Okay, now let's look at a slightly more useful tag helper. Here we have a tag helper that takes three attributes, total pages, current page, and a link URL, and it generates a paging element using some CSS styles. Okay, that pretty much wraps up our whistle-stop tour of ASP.NET Core for now.
So in conclusion, what do we think of .NET Core? Well, going forward, it's a lightweight and modular framework with a small footprint, and it's probably going to help me to reduce some of my end-of-month Azure compute bills. It's also cross-platform, which means for the first time I'll be able to develop useful desktop apps for Macs and run my websites and APIs on Linux. The biggest problem with .NET Core at the time of writing is newness. When you get past the basics, you start to realize how much is missing. A basic test runner, for example, and suddenly routine things that you took for granted in the old .NET frameworks, it becomes a lot more complicated. So in my opinion, if I was building a simple web app, I would definitely use .NET Core because it's faster, it's lightweight, and let's face it, according to Microsoft, it's here to stay and it's the future. and I might even find it difficult to get my developers to work on it in 5 years' time, going back to the old monolithic .NET. Or so the theory goes. But, and it's quite a big but, if you're developing for a large enterprise system and need all the support of third-party tools for things like testing or integration, then you should probably stick with the old .NET, at least until .NET Core 2 comes out. Just don't wait too long.